pulse width modulation is a type of modulation where one technical parameter, for example voltage, changes between two values. At a constant frequency, a square pulse is modulated whose range width or length varies. The pulse width modulation is mainly used in control and regulation engineering, and can for instance also be used when dimming a light. The pulse is the active time in a pulse width modulation. The pause is the inactive time until the next pulse. The period consists of the pulse and the pause. There are two more important parameters that must be taken into account with pulse width modulation. These are the frequency and the duty cycle. The frequency is the number of periods in 1 second. It is given in hertz. Usually the frequency remains constant and only the pulse width changes. Here you can see a fixed 1 kHz PWM signal. The duty cycle describes the ratio of pulse width to total period of the signal. It is given in %. The equivalent value of the electrical voltage can be changed by varying the duty cycle. This digital technique is widely used to control electrical voltage and power. The average voltage and the brightness of the light bulb depend on the pulse width. In other words, pulse width modulation is the fast on and off turning of a signal within a given time. In pulse width modulation, the modulated signal has a fixed amplitude. If the period duration is constant, then the impulse duration is varied. The average voltage or the effective voltage is dependent on the ratio of pulse and total period duration. This means not the permanent given voltage is varied but the voltage is controlled by the variation of the switching pulse.